and thanks for your patience. So I was saying that JavaScript matters because it's the fabric of the web and increasingly used for server-side apps, Node.js, mobile, and desktop apps with Cordova, React, Native, Electron, etc. etc. So it really matters that we push it forward. And what is great with to make JS better is simply that it's awesome if JS gets better. Our code can improve, our apps can have fewer bugs, and some of these features enable the runtimes to actually run code faster. So we use JavaScript heavily in our new product called Blocks. Many of the features are key to making Blocks a good product. Second, it's also part of the fabric of the web and one of our most used languages. We care that our customers can be effective while using it. So ES6 is awesome. So many cool new things. That's the problem. Way too many cool new things. Some are more available than others, some are more ready than others. It's really confusing and too many things in different state of readiness. So that's why we created this class, to show you the 4 features of ES6 that are both useful and ready to use now. Some of the others will be ready at some point, but you can ignore them for now. We are just going to talk about what you can use today. For 4 good parts, the better vars, better strings, better functions, better sync, and we'll ignore the rest. So normally, when you want to create a variable, you use the var keyword. The var is great, but it has a couple of problems. First, var is always a variable. There is no way to make a constant. If you really want a constant, you have to create a property of an object and override the setter so that it can be set. Another issue is that vars are global to the function. They are defined in, not the block. You would think that the log statement wouldn't work because var here is defined in a different block. And in a language like Java or C#, you'd be right. But in JavaScript, var is global to a function, not a block. Another problem is that the variables are hosted. Look at this code I'm using before I've even defined it. What does this code even mean? Under the hood, the JavaScript engine will hoist the variable declaration to the top of the function. I can sort of see what you think want to hoist functions, but variable hoisting makes it very easy to introduce several bugs. Look at this code with the for loop. The variable is only used inside the loop, but I can still reference it outside. This is just bugs waiting to happen. The good news is we don't have to use var anymore. Instead, we can use const and let. So const does exactly what the name suggests. It makes a real constant. If you try to set the constant, you will get an error. But even better, code lining systems can detect this kind of bugs at compile time. So you can find bugs earlier at development rather than in production. Let is just like var. It's a way to create variables, but it is scoped by block instead of functions. Now it does what we really expect. Look at this for loop. Now the I variable is restricted to the for loop. There is no way it can be used outside accidentally. Also, let is not hoisted, so all of those magic moving variables go away. ES6 introduced a new type of string called template literals. I prefer to call them superstrings. Use it just like a regular string, but instead of using single or double quotes, you use the back quote. So far, so good, but nothing is very different. It does have an advantage of when you need to use double or single quotes inside of a string, you don't need to escape them anymore. But this new strings does some other cool stuff too. So for instance, we finally have multi-line strings. If you need to quote several lines of something, you don't need to escape new lines or do join tricks anymore. Just put in the new lines directly as here and it works. The multi-line supports make it really great for doing templates, which is where another new feature comes in expression escaping. Within a superstring, you can put dollar curly brackets, and anything inside that bracket can be any JavaScript expression. This is way easier and cleaner than double escaping your quotes, and it made all templates tasks easier to build. Here's another example. So let's talk about arrow functions. The arrow functions are different syntax for regular functions. They let you write the same code in a more compact way, along with one very important difference. The this variable means something different. Let's look at some code. Suppose you want to loop over an array to double the values within it, producing a new array. You could do this way or with loop. Sorry, we can do this with a for loop, but that creates extra variables, and it can be easy to accidentally break early or get the index wrong. Plus, it's a lot of extra typing. JavaScript arrays have a function called map, which calls a function on every element to generate a new element, which are then placed into a new array. Still, it wouldn't be nice to make it smaller. The x times 2 par is the only thing which actually does any work. The rest is synthetic overhead. So instead, we can do it with a narrow function like the following. So let me explain what is happening. Our function let us write the same thing smaller. But we can even make it even shorter. So let's remove the white space. That is better. But we can even make it even shorter. So we can remove the return and the braces and semicolon. Then we get a tiny one-line expression which automatically returns its value. That's so much cleaner, right? So in JavaScript, the magic variable this always refers to the object that the function is called on. So the call like this doesn't do what you think it does. When you are using other objects, the context may be different. When you pass a function to somewhere else to be called back, it may not call the function with a different this. When you add event handlers to a button, the button will be this, which is not what we want. This created something known as the self pattern, where you save the correct this using a temp variable called self. It's kind of yucky, but here is another way to solve it. So another way to solve it is to bind a function. Bind forces the this to be a specific object. However, functions give us a better way to do it. They automatically capture the this variable from the surrounding context of where the function is defined, not where it's used. This means you can pass the function to some other place, and now the right version of this will be used. Here's the same code with an arrow function, and now it does what you think it should do. Arrow functions are really awesome. I'll try to use them everywhere I can. They make this sensible again. Another great feature of arrow functions is that they work well with promises. A promise is a new kind of object in JavaScript designed to help with new things that take a long time. JavaScript doesn't have threads. So if you want to do something that might take a long time, then you have to call and use callbacks. So for example, in Node, you might want to load a file, parse it, make a database request, then write a new file. So these operations must all be done in order. They are all asynchronous, so you have to start nesting your callbacks. And this produces what JS hackers like to call the pyramid of down. Massively nested codes. It's really ugly, no? So hard to reason about, and has a lot of nasty corners for bugs to hide. And this is what promise helps us to fight. So what is a promise? A promise is an object that represents a value which may not be available yet. It's promised to have the value in the future. So you can add a callback to be invoked when the final value is ready, like the following. In this way, it's much like traditional callbacks, but promise had a twist. They can be chained. This is great. So let's revisit our code from before. Each of these functions must be called in order, and each depends on the result of the previous one. Using promises, we can do it like this instead. So notice how the arrow function makes this nice and clean. Each callback returns a value. This value is passed to the next one, so all of our functions can be easily chained. So now you will notice that the process file command needs the result of the previous two values. The promise only passes one value. We also don't care what other read file and fetch names happens in. We just want to know when both are completed. We can do that with promise.all. So if we had a list of file names, we wanted to load each file and be notified when they are all done, we can do that with promise.all. This is a utility method which takes an array of promise and returns a new promise that resolves when all the sub-promises complete. Let's look at our previous example again. I'm combining the read file and database call into a single promise using promise.all. The resulting value is an array containing the results of both, so I can put them into process file. I've also used the abbreviated arrow syntax to make the call smaller and cleaner. Now consider what happens if one of these things fails. If the first one fails, we could put in a try catch block. but the next then will still be called. So really, we want everything to stop if the first one fails. Promises have another trick up their sleeves: the catch callback. In this version, if anything fails, it will immediately jump to the catch callback at the end, skipping the rest. After the catch, we can still add more than clauses. Off-promises only work if the APIs we call actually use them. So fortunately, lots of libraries are starting to switch over to promises. But while we wait, we can make our own promises too. So we can do it with the promise constructor. It takes two values, resolve and reject. Each of these are callbacks functions. So inside, you do whatever you need to take. You need that takes a long time, even if it involves multiple callbacks. When you are completely done, invoke resolve. With the final value, this will then be sent the first then clause of whatever you use your promise. If something bad happens and you want to reject the value, instead of throwing an error, use reject, and you can pass whatever alternate value you want. Here is a real-life example. I use Ajax calls all the time, but they can be ugly, like this. Let's wrap this code up in a promise. Now it looks like this. It's still the same basic code, but I can call it like this instead. Wow, that's so much cleaner, right? In reality, I don't need to wrap up my Ajax calls because there is a new web standard called fetch, which already does this for me. But until fetch is supported in all browsers, we can use our own. So promises can be a bit tricky to wrap your head around at first, but once you start using them, I think you really like them. It makes it very easy to pull multiple functions together into a single workflow that makes logical sense, and to properly catch all errors along the way. So that is the 4 awesome features of ES6 that you can start using right now. However, I really want to give you a nice bonus feature. There's a bunch of functions which aren't exactly new. In fact, they have been around for a while, but we can finally use them because they are supported everywhere. So Array has a bunch of awesome utility functions, which work great with array functions. So you'll never need to write a loop again. So for instance, here you have like this for each loop that helps you to loop over an array. You have the map functions, which is really useful to do processing over an array. There is here the filter functions that find all values that match the filter. Here is the sum function that will return true if at least one item matches. There's the find method that will find the first value that matches and stop the iteration. There's a find index that will find the index of the first that match. And finally, there is reduce that helps you reduce the array to a single value. But there are a lot more other functions you can use that are really, really useful. For working with hash maps and other objects, the object API has some other useful functions too. Object keys will give you a list of every property name on an object in a predictable order. I use this pretty often. The structuring, this lets you pull values out of an object by name. It can be useful in few situations, but the best use I've found is extracting functions from modules. Unfortunately, modules are still a mess and don't work the same everywhere, so avoid it for now. Along with destructuring, you can do what with the tricks like default parameters and the spread operator. I find this to be more trouble than they are worth, at least for now. There is a bunch of other things coming in ES6 that are all genuinely useful, but they aren't supported everywhere. So I suggest you to hold off for a while, and this includes symbol, generators, iterators, weak maps, sets, and proxies. There is also a new class syntax. I still use the JavaScript protocol inheritance, but it makes the syntax of defining a class cleaner. So however, it's not as valuable without the new module support, so I suggest waiting a bit longer. Most desktop and mobile browsers support everything I've shown you. However, depending on your audience, you may have older browsers, older mobile hosts that don't support these features. Whenever you want to know if something is ready, go to canus.com. This will tell you what version of each browser support what. So that is 4 awesome new features of ES6 that you can start using right away. More stuff is coming, but you don't need to wait to use this. So get to coding, and now we have time for some questions. So if you want to ask some questions, you can ask them. There is a chat box on the right corner of the screen. Looks like the question has been already answered by our Q&A people. So thanks all for joining this webinar. If you have any further questions, you can reach out to support@pubnub.com. We'll help you. And don't hesitate to check out pubnub.com blogs catalog. Thanks all for your attention, and see you soon.